Below is a pressure volume diagram. In geek speak, we call this a PV diagram. Notice that it looks like a graph, but it's not. And it's not a graph because we'll have processes on this that are not functions. So that makes it not a graph. That's why we call it a diagram. This diagram represents 1,000 moles of a gas. The dot on the diagram represents a state of the gas. Question is, what is the pressure, volume, and temperature of this state of the gas? All right, so I've got it on the graph, on the diagram, and I've got some vertical and horizontal lines already drawn on there to kind of help us out to get started. So I'm going to look for the pressure and the volume. All right, I need to know what my increments are for the pressure, and so these are the increments on the side that I figured out. And the horizontally over on the diagram, it points to 1600. So that's going to be 1600,000 Pascal. See, the pressure it says on the vertical part of the diagram is kilopascals. So that's how many thousands I have. I have 1600 thousands. So that's 1.6 million pascals. Okay, for the volume, you can see I already have the dotted line down. I just need to figure out the increments. So on my diagram, there are the increments. And this comes out to be 0.8 meters cubed on the diagram. So the volume is going to be 0.8 meters. Now to find the temperature, I'm going to use the ideal gas law. PV equals nRT. So I'll isolate it for T, and then I'll use the pressure I just figured out. I'll use the volume I just figured out. N is in the word problem above where it says 1,000 moles, and R is the gas constant that I can look up. So if I plug in all my values for T, I get 154 Kelvin.